Hello everyone, I am Swapnil and today's topic of presentation is image recognition in Flutter apps using TensorFlow Lite. Well, before going to the main topic, let's talk about something that I have observed in my daily surroundings. While going through the Liquid Galaxy apps, I stumbled upon something called Crop Dog. So what's Crop Dog? So it is an application. You take the picture or upload from gallery the image of a leaf, and it returns its status, like whether it is healthy, whether it is having some disease. So who is behind the lens doing all the work? Or forget it. Let's get to the generalized case. There we have Google Lens that we almost use it every day. What Google Lens does is, if we click the image or the screenshot of something, we can get results similar to that. So who is really behind this, doing all this stuff? It is the machine learning model and the deep learning model. So there have been a surge of machine learning, as we have the Liquid Galaxy 2024 year as the year of machine learning projects. So these are currently on surge and have been easing our lives currently. So there are various aspects to it. Specifically talking about Google Lens, there are a variety of things like text recognition, object detection. In the case of Crop Dog, it is image recognition. Well, wait, image recognition, right? This is our topic. So, what is image recognition? Image recognition is scanning or taking the photo or some image, uploading it, and there is that machine learning model behind our backend working its way to give us the output has some text label, or so to say the label. There are labels that have been assigned to it while training, like in this case of leaf there are certain labels like healthy, there is some gall midge or some other kind of disease that have been decided to train a large amount of model, and it serves the purpose of even larger data set that we will work upon in real time. So right now we're not talking too much about ML. Our work is how to deploy it in an application. First of all, let me explain you what are the various ways that we can achieve our deployment. First of all, the most common used method, that is Flask. Flask is used along with Dockers nowadays, or the AI servers, in which we create the H5 of an ML model, and broadly it is used as an API call. It generates HTTPS, and we give our input, the in this case the image input, as a JSON object, and it returns the output or the label as another JSON object which we need to decode. Well, this is a more dynamic way of approaching that. But there is another thing called ML Kit, the Google ML Kit. Well, Google ML Kit is so simple for Flutter. There is a simple pubdev dependency that we can just copy paste it, and there is a model that works in a great way. But there are certain limitations to them. For the Flask model, the Flask model have to be uh, approached using a Dockerized AI model. It requires a lot of internet, and we have some kind of request going on, so it makes us wait. And in case of ML Kit, what it does is has some certain sample models. It is not customized. It is not tailored according to our needs. We are training our dataset manually. We need our output according to that. So what are we left with? Yes, TensorFlow Lite. So, what is TensorFlow Lite? TensorFlow Lite is a lightweight version of TensorFlow designed using TensorFlow only for running machine learning models on mobile, embedded, IoT devices, and even Raspberry Pis, which are one of the focuses of the Liquid Galaxy projects this year. So we have created our ML model, but the real target here is how to work it out, how to how to bring the best out of it in applications, in websites. So for that reason, TensorFlow Lite exists. It is an optimized version of a deep learning or neural network model, which can directly be employed in some kind of application to do the task without any hassle. So there are multiple ways to make it. Let me show you an example. There is this mod. This is the official example that has been provided by TensorFlow. It automatically creates the model, and our focus is not on the model. We are not working on ML. So that this function is what works for us. The model dot export, it exports to the default directory in our Google Drive, as a TFLite model. And if we go into the details, there are three types of things. Like three types of export methods that we have. Like one is the export format the TFLite, second one is export format that label, and the third one is export format that saved model. I would prefer export format that level, because you will see later while we are coding, while labels are important, we need the labels to be integrated along with the TF-Lite so that we can have a smooth output. The output can be classified according to its label correctly. So there are a lot of metadata also involved, but there is also this TF-Lite has this feature to avoid the metadata and create the stuff default by default. So there are a lot of use. Not only this, we are also working on voice this year. So we have other tasks like object detection, speech recognition, text translation, and even text detection, or the works that Google Lens does usually. So it has a broad base of works to do, each of them bringing to a small 2 or 3 MB of file that we will work upon in our Flutter application. So let me go through the architecture of our TensorFlow Lite model, how it is going to work on our cross-platform applications. So when building with Flutter, our main target is how to achieve the best result in both Android, iOS, and even in things like it works in web and Safari, like Chrome, Safari. So Flutter is really a dynamic application maker. So we need to train our TensorFlow according to that. First of all, after training our TensorFlow model, there is this converter that I showed using the dot export function, using one of the three methods. We will have the TensorFlow Lite converter. It converts to dot TF-Lite model. Now it's on us to download it, paste it in our application, or the assets of our application. In the case of Android app, it has the Java API, the various layers of the APIs, like the Java API, C++ API, Java, because we are in the case of Android, we are working with Java also. C++ is common for both Android and iOS, as it is the real basic framework behind all this. Then we have the interpreter, which uses the kernel to work on the core of the mobile phone to derive a result. In case of Android, there is this extra thing called Android Neural Networks API, due to its smooth collaboration. I would say collaboration with TensorFlow to work upon it. And iOS, it is actually a simpler thing, only C++ API along with the interpreter. So, but there is a thing, why I have chosen TF-Lite only, why not the first two methods? What are the advantages of TF-Lite first of all? So I will talk something that has happened recently, our announcement. There is the LGI server that is completely deprecated for now until we receive further updates. Our main job is to focus on avoiding dockerizing models. So the only option we're left with, if we want to make our own custom models, is TensorFlow Lite. we'll have our own data set and it will be integrated locally. It has really low latency, it runs locally and has offline influence. So it does not require internet. It can be run offline because it is already integrated within the download size of the application. We can smoothly work upon it without bothering about if the internet is available or not. It gives the same result in both the cases. Next point is it is lightweight and optimized for mobile phone. You can observe it clearly whether it is a very big data set, it is trained, the ML model took hours to run. But once I it exported to a TFLite model, it's hardly 5 or hardly 10 MBs. So it is a great option for mobile phones which have comparatively lesser storage than computers. It has cross-platform compatibility. We already talked about that. When developing in Flutter, we need that cross compatibility, which is really a plus point of TFLite. And yes, direct and easy deployment into device. We'll see that soon, that how easy it is to code and deploy it to gain our results without any hassle. It supports GPU and TPU acceleration. Yes, we have the target of using Raspberry Pi and stuff. So GPU and TPU acceleration is really important given that we need to get faster results. GPU and TPU work upon running it faster than the normal computer process when we run it in Google Colab or in Kaggle. When these are enabled, these provide a real-time speed and make our work easy and fast. And finally we can train custom models. Training custom models is a really helpful thing given that we are snatched up from the option of dockerizing things, because we have limited number of options and we have to do something that caters to the need of the project or the application that we are working on. So TensorFlow Lite does the job. Now let's get real. We have to code the thing. The step 0 is, first of all, for implementing TFLite. For what do we need? A TFLite model. Yes. This is the example that I provide, the same that I show you here. This is how you create a default model and just export stuff. So you can go through it, where I am not working too much on it. I have already a model with us that I will be providing you through GitHub. We will focus on the Flutter part and let's code. We'll import our dependencies into PubSpec YAML. These are the two dependencies. One is the image picker, other is the TFLite v2. Image picker, what it does is we have to upload the image using gallery or camera. So this image picker pubdev package really makes it fun. It is hardly 2 lines of code that we will be implementing to open the camera or open the gallery and assign the image to be run through our TFLite model. These all are available in the GitHub repo. You can feel free uh, to clone and work upon it. Also the TFLite model has been provided earlier. Let's work on the before starting. I would want you to confirm these things are working or not, because this gave a lot of trouble to me. You have to go to settings.gradle. Under this Android folder there are two things. One is the Gradle wrapper properties and settings Gradle. Please ensure that this .com.android, that application, is at least the version that I am using. Same for the Gradle properties, it is at least the distribution URL, this 8.4 or above, because I faced a lot of trouble while deploying TFLite in a Flutter application. So it will be helpful. And finally, we have the TFLite. Toast is completely optional for you. You can just stick to simple print statement. I will run pub.get. We have got our dependencies, image picker and TFLite v2. Then, but wait, There is one problem with this TFLite v2 dependency. It troubled a quite lot, so I have decided why not just remove it from root. Before starting, I would say why I still prefer to go with this dependency only. There are multiple dependencies. There is that one dependency like TFLite Flutter, but it has to be used for specific use cases. There is another dependency that has to be added, that is TFLite Flutter helper, which makes things more complex and not so convenient to code. I would prefer it if I am working on this easier module, it is worth it to edit one line of code. So you can head to the directory that I have provided in my screen. For Mac users, it is users slash your username slash dot pub cache slash hosted slash pub dot dev. For Windows, it is c slash users slash your username slash app data slash local slash pub slash cache. So you have to find this specific file named TFLite v2, and within that Android. So I have already this opened. I'll open it real quick. You can you can you can go to, so the directory that I have shown you looks something like this. This consists all the pubdev dependencies that we have uh, uh, that we have imported over years. It is a kind of cache keeping all this intact. I'll open the TFLite v2 folder, then the Android folder. The Android folder has the build.gradle. The build.gradle, I have already opened this. I'll show you this. This looks something like this. Like the module build.gradle is very similar to uh, that of an application, but there was one line that troubled me. This line will not be available in the real code. So this namespace equals to sq.flutter.tflite. Under Android, you have to add this line. Let me just uncomment it. I have also shown here. You can just simply copy paste it, this, and our project is ready to be worked upon. Now our step 1 is upload the image locally. For uh, for this stuff, I have two tasks to really work on it. One is selecting from gallery and the other is taking a picture. So first off, I will go to my Android Studio Code. There are a bunch of to-dos, so we have to uncomment each of them. I have now here I have written define the functions to upload an image. So in this pick image package, what it does is it pick image and take photo. So what does pick image do? It takes this image source as gallery, and we select the object from gallery. And now as I have uncommented it, let me also uncomment here pick image and this one. These are the elevated buttons. These are kind of simplistic. You can extend your creativity to do. This is the upload image from gallery and upload image from camera. There is the X file. The X file function really opens the picker, really finds the picker or the image picker, activates the image picker object that we have derived here, that we have defined here, to open the gallery or open the camera. It changes that activity. It works like intent, so by which we can find the necessary image path and assign it to the file path is also something that we have already defined here. It is but you have to take care of that. While initializing it, it has to be null, because a late initialization, where if not initialized properly, will show errors. Now that I have initialized it, I have defined my functions, I have assigned them to the unpressed of our buttons. Let me do a hot restart. Now it should work properly. Yes, as I click on see from gallery, it loads all the photos I have, and when clicking on take picture, it loads the camera. Here is the little guy because it's just simply an emulator. So this, we are done with this part. Now next we will implement the model. What we're really working on, the TFLite model. I have provided them in the, you can go through some you can do some research on the mango disease classification, because that's what the that's what I'm going right now to implement. We're going to implement it right now, the mango disease detection model. There are three labels to this which has been assigned here. Name this labels.txt file. I had talked about that before, right? Okay, I will why I have imported it as why I want to export the file as a label mode. Here are the labels.txt file that we will be soon assigning to our model. There are the three labels, namely Golmage, Healthy, and Sooty Mold. This is all we have to work upon to implement our mango disease detection model. Now our next to do is to define the functions to initialize the TensorFlow Lite model. One thing before doing this, you have to go to your dependencies and add the assets folder under the assets, and again run the pubget to be sure that you can be able to use these files. There are three files here that I have used. Let me initialize the TFLite function first. Here, well, yes, before that I have also another thing to do. We have to import the packages from the pubdev. We can't work on them directly, so let me uncomment this also. This is the TFLite v2 Flutter toast, and the image picker is already running. After uncommenting this TFLite setup, this function, the TFLite load model, what it does is I give the input as the path of this TFLite file, the path of the labels file. It will read the data inside this to execute and implement about the input that we give under the TFLite model that has been already trained. So these are some of the initialization, like number of threads, assets, and uses CPU delegate. These are by default and completely optional if you use them or not. The here, while initializing it, we have to use this function. In its state, I have to initialize the TFLite model, and now we will return to the real model that we will be running. Next to do is to run the model on image. I will uncomment all of this. First, a bunch of null checks that we have to do to make sure that we are safe. We will check the file path. We will first of all we will see if the file path is null or not, because if it does not make sense, right? If we have not provided any, if you have uploaded an image, the default image is loading, so it should not work. So it's completely on you to show the toast, but you can simply print this statement, pick an image, and if we are through this check without returning it, we will go for the actual recognition model. This is run model on image function of TensorFlow Lite. We have to provide the file path, the path of the file path dot path. It is nullable, so we have to insert the null check first. And these are the pre-processing parameters, like the mean, standard deviation, the number of results, the threshold. These are really important while executing and implementing an ML model, because there are some uh, modifications that had been done during running the model. So we have to do the same modification in order to achieve the best results according how the model has been run. Here another null check that we are following along with, because the recognitions should not be empty. It will give some error in the prediction or the confidence that we need to fetch here. We can't have really some null value assigned to a text widget, so we have to take care of this. It again shows a simple statement and returns the function, and after all these checks, if we have passed, then we are assured that our model has run successfully. We have our prediction and we have the accuracy or the confidence. It is fetched as a JSON object, and the recognitions level, recognition confidence, this is a double value, so I have to convert it into string. These two have been fetched successfully. We have to also another thing, while disposing, we need to dispose our TFLite model, because it really causes some trouble in while working with the deployed application that has been already released. Let me do some quick initialization of an asset that will be actually using to upload the image. This is an image that has been conditionally set, because if the file path is null, it needs to show some default values. Therefore I'll hot restart it. Yes, it will show this blank.png that I also have downloaded in my assets folder. If no image is there, just to indicate that you need to upload an image, and on successful upload, it changes the file path to our desired image. And fi- finally, the culmination of all the hard work that we have done till now, uncommenting the elevated model that says predict. We are ready with the image. We just need to go through the model, run it by clicking a simple button named predict, and it will show the prediction and accuracy. uh, Again, some hot restart. I have a bunch of leaves that I have already saved in my gallery. I'll select from gallery, click one of these. So this conditional check has paid dividends, because as we are assigning some value to our file path, the blank image is changed to the desired file path that we want to work on, which out of which the similar thing that we can take while taking a picture. Right now I'm focusing on downloading it from the gallery, uploading it from the gallery, and I will hit the predict button now. Okay, I forgot one thing. We need to initialize it again, because of this function. The what error I was doing is, we have this TFLite setup, which has to be, due to which it has to be hot restarted again. After doing the hot restart, it works. So again, I will select the image from gallery, then I will predict it. As you can see here, our model has run perfectly with a confidence of 0.9998, that is 99.98%. That means it has run perfectly, and we have achieved our desired results. So this is how simple we can work a complex ML model with just a 2 MB file, and uploading in image, and then getting our desired product. There is addition that I have done to the top by adding a button that really cleans the image, the predictions, and the accuracy, as these are the variables that can be edited real time due to being stateful widget. So I can click on this, and it sets the file path to null, prediction, the accuracy become empty, and we are back to our default settings. uh, Before concluding this, I would like to say that TFLite is not restricted to image classification. There are a broad variety of things that we can work upon to, like object detection and all that I have said before, which can be applied real time in our Liquid Galaxy applications to get some results that might help the humanity, or the for educational purposes, to be aware about the, like, in this case it was aware about what are what disease it is, the mango disease is acquiring, or what it has to, in order to take our steps necessarily. There is a broad range of things that we need to discover. So the and another thing is speech recognition, which also acquaints us with things like speech to text in, we can search through pubdev packages and go through it. And there are a lot of tech stack that are also involved in Flutter. As we saw here, there is this image picker to image classification. In the same way, there is the text to speech in text recognition, or sorry, in sound recognition or sound classification, that we really need to work upon in order to bring variety and ease, and most importantly serve to the humanity using these machine learning models, using TFLite. So that's it for my presentation. Thank you very much.